Okay. So the first important concept is latency. So what is latency? It is a delay between sending a request and receiving a response in a system. So what we have already seen that we will see a client server architecture, and we are going and our platform will be web. Okay, and we will use MVC design pattern. Now we have a client and a server. Client sends request to the server, and the the server sends response to the client. Okay, so basically you will see this is one request response cycle, so we call it as round trip time. So first the client will send request to the server, then the client will have to wait for the response to come from the server. So this is one round trip, so we call it as round trip time, and we also call it as latency. Okay, the first important formula is speed equals to distance upon time. You all will be familiar with that formula, right? So if we want to calculate time, how do we calculate time? Time is equals to distance by speed. Okay, and in latency, as I said, latency is equal to round trip time. If there are any additional delays, we will also add that. Okay, now we will come to our first question. Suppose a client machine A is communicating the data center B located 8,000 km away from A. How long will it take for a response sent by server to reach client A? Okay. So what is said, how long will it take for a response sent by server to reach client A? So what will happen first? The request will go from client A to the server. After that, the response will come from server B to client A. So basically, they are asking us about latency. Okay. So what is latency? Latency is round trip time. So this is request time. Request time is when request is made from client to the server. So that is request time. And the response time is when the server sends response to the client. That is response time. Okay. Now here, what is given? What I said, speed is equals to distance upon time. So what is the distance? Distance is 8,000 kilometers. So request time will be 8,000. Just note one thing. Whenever solving numerical, just make sure that you are balancing all the units. Okay, here the distance is given in kilometers. Okay, so we will first convert it into meter. Why we are converting it into meter? Because the speed is given in meter per second. Here it is written as 2e8, so it is just a notation which means 2 into 10 to the power 8. Okay, so here it is given as 8,000 kilometer. So we will convert this into meter. So this is in meter, divide by, this is my distance. Now what is my speed? The speed is given as 2 into 10 to the power 8 because communication is happening in cable. Okay. So what is my speed? Speed is 2 into 10 to the power 8. So this speed is in meter per second. Okay. So if you divide it like this, so answer will come in seconds. So this is my request time plus response time. For response time, again the distance is 8,000 kilometer. So we will convert it into meter. Divide by okay, and there are no additional delays. So now this will be equal to 2 into 8,000 into 1000 divide by 2 into 10 to the power 8. So if you calculate this, there are 8 zeros over here. That is 10 to the power 8. There are 6 zeros over here. So it will be cancelled. This 2 will be cancelled. So this so here this 10 to the power 8 is in denominator. So when it will go to the numerator, it will be 10 to the power minus 8 multiplied by 10 to the power 6. So it will be equal to 2 into 10 to the power minus 2. So here, as I said, this was in meter and this was in meter per second. So final answer will be in seconds. It is a general convention as distant as The time is very less, so we calculate it in the form of milliseconds. So 2 into 10 to the power minus 2, this will be equal, sorry, not 2, 8. This 2 gets cancelled, okay? So 8 into 10 to the power minus 2, this is equals to 0.08 seconds. This will be equals to, now this answer is in second. 1 second is equals to 1000 milliseconds. Sorry. So if we want to convert it into milliseconds, we will multiply it by 1000. So 0.08, when we multiply it by 1000, the answer will come in forms of millisecond, and this is equals to 80 millisecond. Is this question clear to everyone? Any doubt in this question?
Ma'am,
Yes.
ma'am, latency and round trip time is equal same.
Yeah, they are same.
Okay.
What
It
I
means
said, latency is the delay between sending a request and receiving a response. So first request will go, then we will receive response for. So this is one request response cycle. That's why we call it as round trip time.
ma'am, there is a
Okay.
one delay. What is delay? You have not calculated delay.
We will discuss in the next problem.
Okay.
We have such problems. Yeah.
Ma'am,
Yes.
ma'am, in the previous question, they asked to calculate the request time, not the response time. But why you take that response time also?
First the request will go, right? After that only we will receive response.
Ah, okay, okay.
First request will go from client to server, right? Only after that response will come. So how long the client will have to wait for the response? It is
Yeah,
request
got
time plus response time, right?
yeah, yeah.
Okay, we will move forward to next question. So
Ma'am,
there
there
can
is
be
a
different
document will
types
be
of.
shared.
Yeah, I will share this document under supplementary content. So where you can find it. So here there is one supplementary content section, right? Here there is solve with instructor source code. When you go to this section, you will find all the resources so far shared with you. Okay.
Okay, ma'am.
So this is very simplest type of problem. These problems are very important. You will find such problems in your quiz. Okay. So this is a very basic concept. After that, there can be changes of medium, or we will add delays to it. So these are the variety of problems. Okay. Now we will move forward to the next question. Here, suppose a client machine C is communicating the data center D located 15,000 kilometer away from C. Assume that the TCP connection has been established and is kept alive if each new request can be sent only after receiving an acknowledgement from D for the previous request. Then what is the maximum number of successful requests that can be sent from C to D in 1 second? Okay, so what is asked? We have to calculate maximum number of successful requests that can be sent in 1 second. So if we want to calculate number of requests that are there in 1 second, we first need to calculate the time required for each request response cycle, right? So basically, we will first calculate the round trip time. After that, we will calculate the number of requests made in 1 second. Okay. So first, what is given? The TCP connection is being made. So TCP is transmission control protocol. So first, this TCP connection is made, and only after that data is sent. If the connection is broken, there will not be any request or response cycle. Like request will not go to the server or response will not come from the server if this connection is broken. So now what is given, this connection is alive for 1 second. So now what will happen? First, the request will go from client to the server. After that, we will receive response from server to the client. And what is said, each new request can be made only after receiving an acknowledgement from D. So what will happen first? This first request will go. I will receive response for my first request. So I got the acknowledgement for that. Only after that I can make the second request. Like that we will proceed. Okay. So if we want to calculate total number of requests that can be made, which means, yes, Abhinav?
Acknowledgement is response, right, ma'am?
Yeah.
Okay. That is what my question is.
Acknowledge. Yeah. So so what will happen? So first request will go, then I will receive response. Only after that I can make my second request. Okay. So for all the successful request that can be made in 1 second, we need to first calculate the round trip time. Are you getting why we are calculating the round trip time? Because first the request will go, only then I will receive response. Only after that I can make second request. So this is round trip time. So we will calculate the round trip time first. So how will you calculate the round trip time? We have already seen over here, right? So here, as the distance is same and there is no change of medium, so we can directly calculate it as 2 into distance is 15,000 kilometer multiplied by 1000. Now the speed is given as 2e8, which is 2 into 10 to the power 8. So the answer will come in seconds. Since 2 gets cancelled, this 10 to the power 8 will go to numerator. So the answer will come as 0.15 seconds. So this is the time required to make one request response cycle. So we have to calculate how many such request response cycles can be made. Okay. So here this is 0.15 second. This is equals to 150 milliseconds. Okay. Now what is the time given? The time is given in second, that is 1 second. Now 1 second is equals to 1000 milliseconds. Okay. Now we want to calculate number of such successful requests which can be made. So we call it as, so we will say it as n. So it will be equal to, the time is given in seconds. So 1 second is equal to 1000 milliseconds divided by 150. Because for each request response cycle, it is taking 150 millisecond. If we want to calculate such request, how many successful such requests can be made. So we will divide that time by this 1 second by 150. This is the time required for each request or each successful request response cycle. Okay. So now can somebody calculate this?
It will be
So
like
the
six.
answer will come as 6.67. It is 6.67. Okay. Now this answer cannot be in fraction, right? The number of successful requests that can be made, this answer cannot be in fraction. So we will have to think whether the answer is 6 or 7. So we will just break it down. We have 1000 milliseconds. Okay. Now the first request response cycle is made. It took 150 milliseconds. Okay. This is for first request. Then this is for second request. Then this is for third request. For fourth request. Fifth request. Sixth request. Now, if we calculate this total time, it will become 900 milliseconds. Okay. Now we are only left with 100 milliseconds. Now, what will happen till sixth request? We are able to make 6 successful requests. Okay. So it took 900 milliseconds. Now the request will go from C to D. Okay. Like from client to the server. So while making this request, it took, so while we make the seventh request, it will take 75 milliseconds, right? Here the round trip time is 150. So for the request time will be half of it, right? So it will be 75 milliseconds. So now we are left with how much time? Only 25 milliseconds are left. So in this 25 milliseconds, we are not able to get response from the server, right? It is not possible because we will require 75 milliseconds. But when the server was sending the response, this TCP connection was broken. So now the response, the client will not receive response from the server. That's why we are only able to make 6 successful requests. So the answer for this question is 6. Any
Excuse me,
doubt
ma'am.
in?
Yes, ma'am, I
Yes.
have a doubt. Ma'am, I have still a sufficient time to make seventh request. Why the answer is six?
What is the meaning of like what is the importance of request if we are not getting any response? Here it is given a successful request, which means that you are receiving a response for the request that you are making. It is not simply just you are making request and you are calculating how many requests you are making. It depends like whether you are receiving response for that request or not. Only then there is meaning for the request that is being made. That's why here the answer is 6.
Okay, so
Here
it's complete round trip.
yeah, it's round trip time. Because
Okay,
if I
got it,
am
got it.
sending a request, then obviously I am expecting the response. Only then there is a meaning for that request, or I can say it is a successful request, right? That's why here the answer is 6.
But ma'am, by the calculation, we know the request will be reaching to the server, but we will
Hmm.
not get any response. So is it a successful request or not?
It is not
By
a
the
successful
calculation.
request. Yeah, if we are not receiving response for the for the request that is being made, then it is not a successful request. That's why here we have seen, right, till 6 request we are able to get the response. But while I was making the 7th request, the connection was not there. It got broken. That's why we are only like the request was made, but we are not receiving the response for that. That's why the answer is only 6 successful requests. I
Got
hope
it.
this is clear. Okay. Now we'll see the third problem. This is regarding the change of medium. Consider a client which is located 6,000 km away from the server and makes a request through the cable. Okay. Suddenly, after the request reaches the server, the cable breaks and the response is now to be sent to the client via air. This change of medium caused an additional delay of 75 milliseconds at the server end. How, how long will the client have to wait before receiving the response? Okay. So here also we will have to calculate latency. So here the client was making request to the server. At that time the medium was cable. Okay. Then the cable was broken. So now the response will go via air. So there is change of medium. So this change of medium will cause the change of speed. Okay. So here for cable, the speed is given as 2 into 10 to the power 8 meter per second. And in air, it is given as 3 into 10 to the power 8. Suppose the speed is not mentioned, by default, you can take the speed in air, that is 3 into 10 to the power 8. Okay. So now, what will be the round trip time here? We will also need to add the delays that are mentioned. So here, unlike this, the request and response time will be different. Even though the distance is same, the time will be different because the speeds are different. What is time? Time is equals to distance by speed. Here, even though the distance is same, the speeds are different. So the request and response times will be different. Okay. So what is the request time? So the distance is 6,000 kilometer. Is in kilometer. Divide by. So at that time, the medium was cable. So we will divide it by 2 into 10 to the power 8. Okay. So here, this answer will come in meter in seconds, because here is in meter and here it is in meter per second. So the answer will come in seconds. Okay. Plus, but while sending the response, now the medium is changed and also there is a delay. So we need to, so the total response time will be the time to reach the response from air, sorry, from the server to the client plus this additional delay. So Again, the distance is 6,000 kilometer. We convert it into meter. Divide by, now the speed is 3 into 10 to the power 8. This is also in meter per second. So the answer will come in second, plus we have the delay. Now, as I said, while solving the numerical, be aware of all these units. Now it is given as 75 milliseconds. So now if I want to convert it into seconds, what I will do? I will multiply this by 10 to the power minus 3 to get seconds. Why? Because 1 second is equals to 1000 millisecond. So if so what is one, if I want to convert the millisecond into seconds, I will multiply it by 10 to the power minus 3 or divide by 1000. So 75 milliseconds will be equal to 0.05 0.075 seconds. How we did that? Here I simply did 75 divided by 1000. Okay. Now this will be equal to, so 2 threes are 6 here. This will be in, this will go to the numerator, 10 to the power minus 8. This is 10 to the power 6. So this will be equal to 3 into 10 to the power minus 2, or we can also write it as 30 milliseconds plus, here 3 twos are 6. Okay, first I will write it in seconds, otherwise it will cause confusion. So this is equals to 0.3
0.03.
0.03, yeah, 0.03 plus 0.02 plus 0.075. So this will be equal to 0.125, I guess. Yes, this will be equal to 0.125. This is in seconds. Okay. Now, if you want to calculate this in milliseconds, so this will be equal to 125 milliseconds. Is it clear? So what is the time required for the client to receive the response? It will be equal to 125 milliseconds. Is it clear?
Yes,
Oh, yes, sir.
Yes,
Okay.
ma'am.
So this is important problem because there is change of medium, and also the it was given in 75 milliseconds. So you can just be aware while solving such problems. Okay, always take care of the units. Now we will move forward to the next question. Here you must have seen this question. This is a practice question. A client C and a server S located 12,000 kilometers apart and connected with the help of a cable. Okay. A request was sent by the client C to server S, but while sending back the response to the client, the cable breaks and the response is now sent back via air. Okay. This change in medium caused an additional delay of 20 milliseconds. As compared to the round trip time of a healthy network, the round trip time of the faulty system would be. Okay. So we have to compare these two round trip times and we have to check whether it is increasing, decreasing, or remaining same. Okay. So we will first calculate for the healthy network. So this will be case 1. So how do you calculate the round trip time? So for the healthy network, it was going, the medium was cable. Okay. And the distance is 12,000 kilometer. So the medium was same. For healthy network, the medium would be same, right? So we can directly write round trip time as 2 into the distance was 12,000 kilometer Okay, we will convert it into meter. Divide by the speed will be 2 into 10 to the power 8. Harish, can you please join by your official ID? I think you have joined from your personal ID. Please drop the call and join from your official ID. Okay. So the speed will be 2 into 10 to the power 8. Now this is equals to, this 2 will be cancelled. So the answer will come as 120 milliseconds. This will be equal to 120 into, so like you can directly write it as 120 milliseconds. Okay. So now we will see the another case. Okay. So first the medium was cable, then the medium was air. Okay. So in second case, when there was a faulty network, so first, so now here the request and response time will be different. Okay. So for the request time will be equals to, the distance is 12,000 kilometer. So 12,000 it was cable. This is my request time. Okay. After that, the response time will be equal to this 12,000 divide by, 12,000 multiplied by 1,000 divide by 3 into 10 to the power 8, plus there are additional delays. Delay is given as 20 milliseconds, 0.02, because this answer will also come in seconds. So if we calculate this, so here it will be equal to 2 6 are 12. So 6 into 10 to the power minus 2. So this is equals to 0.06 plus, here it is 3 4s are 12, 0.04, plus there is additional delay of 20 milliseconds. So we will add this 0.02. Okay. So if we convert it into milliseconds, it will be 120 milliseconds, or I can write it as 0.12 seconds. This will be equals to 120 milliseconds. So in both the cases, even though there was change of medium, but when we calculated the round trip time, so for both the cases, it is coming as 120 milliseconds. That's why the answer is remains same. Is it clear to everyone? Any doubt in this question? Okay. So you can find such problems in your quiz. So these numericals are very important. So just go through this once again, while I will share this after the session. Okay. Now we will see next problem. Now
Ma'am,
there, yes,
could you also discuss the summary of the week in this session?
it was already taken by TA, and the link is already available in the YouTube channel. You can refer that. As such,
It
week
it
one
is
is
not an open
concerned.
session.
Yeah, I am discussing numericals, right?
Okay, okay.
See, you have to focus more, just don't focus more on the theoretical part. As I said, week one is regarding the introduction, is a regarding introduction to the content. Okay, so you will find a lot of terms over there. So you don't have to. It is just for your knowledge. It's just for an overview. You don't have to remember everything, like all the theory as far as your quiz is concerned. All the important topics or which are there in the uh, content will be covered in the sessions. Okay, so you don't need to bother about all the theory which is there in the session. But for you, I asked the TA to take the week one summary, so that link is already available in the YouTube session. So you will find a playlist, like TA sessions. In that you will find that list, or you can
Okay.
also find that link from the calendar.
Okay. Okay. Thank you.
Okay, now we have seen the latency. Now we will see bandwidth. Now, bandwidth is a measure of how good your network connection is. Remember one thing, the bandwidth is always given in the form of bits, gigabits per second, megabits per second, but we are usually familiar with bytes. Okay, so bandwidth is given in bits, that is small b, that is bits, and the storage or size of request are generally given in bytes or asked in bytes. Okay, which is capital B, that is bytes. Now we will see the bits and byte conversion. 1 byte is equals to 8 bits, or 1 kilobyte is equals to 1000 byte. See, for the ease of calculation, we won't take 1024, we will take 1000. Okay, for the ease of calculation. So even if it is not mentioned, we will take 1000 only for the calculation. 1 kilobyte is equals to 1000 byte. 1 megabyte is equals to 1000 kilobyte, or 10 to the power 6 bytes. 1 gigabyte is equals to 1000 megabyte, or 10 to the power 6 kilobyte, or 10 to the power 9 bytes. 1 terabyte is equals to 1000 gigabytes, or 10 to the power 6 megabytes, 10 to the power 9 kilobytes, or 10 to the power 12 bytes. Okay, in time conversion, 1 second is equals to 1000 milliseconds. So if we want to convert milliseconds into seconds, we will multiply it by 10 to the power minus 3. Okay, 1 microsecond is equals to 10 to the power minus 3 milliseconds. This is equals to 10 to the power minus 6 seconds. 1 nanosecond is 10 to the power minus 3 microseconds, or 10 to the power minus 6 milliseconds, or 10 to the power minus 9 seconds. Now, 1 million is equals to 10 to the power 6 units. Okay. 1 billion is equals to 10 to the power 3 million, or 10 to the power 9 units. 1 trillion is equals to 10 to the power 3 billion, or 10 to the power 6 million, or 10 to the power 12 units. Okay, so million, billion, trillion. So the difference is 10 to the power 3 for all of this. Okay, now we will see bandwidth. So there are two formulas for bandwidth. Bandwidth is number of requests per second into size of request. Also, I will write over here. Here there are two formulas for bandwidth. Bandwidth is equals to request per second into size of request. So the bandwidth is in, you can see what is the unit of bandwidth. It is gigabits per second or megabits per second. Okay, so from the unit you can also write bandwidth as data transferred per second. Okay, so we will this numerical is based on this first formula. So we will see this first question for bandwidth. For a network bandwidth of 8 Gbps, what should be the size of each request in megabytes if 5,000 such requests are to be sent over the network per second? So here the bandwidth is given, number of requests are given. We want to calculate the size of each request. Now here, what here it is given as 8 Gbps. Now, what is the conversion between GBps and Mbps? 1 gigabyte is equals to 1000 megabytes. Okay. So here I can write it as, here it
Ma'am,
is
it's
given.
a
So I can,
small b, so it
what,
will be gigabits or gigabyte.
the conversion, just focus on the conversion. 1 giga is equals to 10 to the power 3 mega.
Okay, okay.
It
Got
is
it.
in terms of bytes, but here it is given in terms of bits. The bandwidth will be always given in terms of bits. Okay. So I can write here, this is giga. So giga is equals to 10 to the power 3 mega. So I can write this 8 Gbps as 8000 Mbps. Okay. Now,
Okay, ma'am.
what are the number of requests? It is 5000. So 5000 requests are made per second multiplied by size of request. So my size of request will be 8000 divided by 5000. I just converted it into Mbps for the ease of calculation. Okay. So this will be equals to 1.6 mega. Now it will be bits or bytes?
Bit.
Bits. Why it is bits? Because here the bandwidth is in bits. So this will be equals to 1.6 megabits. But I want to calculate the size in megabytes, and generally the storage is mentioned in terms of, or size of request, it is mentioned in terms of bytes. So what we will do, we will divide, how we will convert this into bytes by dividing 1.6 by 8. Okay. So this answer will come in terms of bytes. So this is equals to zero point 0.2 megabyte. Is it clear? Is it clear?
Ma'am, can you repeat once?
Any doubt in this question? Okay. What is my bandwidth? My bandwidth is number of request per second into size of request. Okay. So here I have written bandwidth is equals to number of requests per second into size of request. Now, always here the bandwidth is given in gigabits per second. So bandwidth will be always mentioned in terms of bits. Okay. And storage or size of request, they are generally you can be given in terms of kilobits also, but generally the storage is mentioned in terms of bytes. Okay. And here
Okay.
it is asked in terms of bytes. So we have to maintain that calculation. Now, first thing, this is 8000 gigabits per second, 8 gigabit per second. Okay. So I converted into megabits per second. Now 1 giga is equals to 10 to the power 3 mega. So this 8 Gbps, I can write it as 8000 Mbps. Okay. This is equals to, we are given that 5000 requests are made per second. So I will write, so here it is, I wrote 5000 multiplied by size of request. So we want to calculate the size of request. So what will be the size of request? 8000 divided by 5000, right? Simple calculation. If I
Yeah.
want to calculate the size, I will divide 8000 by 5000. So this per second got cancelled. This is megabits per second, or I can also write it as megabits per second. Okay. Here I can also write it as megabits per second. So here this per second got cancelled, and I will get the answer in megabits. So I got the answer as 1.6 megabits, but in question it is asked in megabytes. So how, so we know 1 byte is equals to 8 bits. Okay. So if we want to convert these bits into byte, we will divide by 8, right? So we divided by 8. So we got the answer as 0.2 megabyte. Clear?
Yeah.
Excuse me, ma'am. Uh,
Yes.
you converted gigabits into megabits for ease of calculation, or is there any rule to convert gigabits into megabytes before the calculation?
Just for ease of calculation, I, this would have, otherwise this would have been 8 Gbps divided by 5000. So anyway, you had to convert it, right? That's why for ease of calculation, I took it as 8000 Mbps.
Hi, ma'am.
Got it.
Okay.
Hello. Hello.
Yes.
Ma'am, can I ask something?
Yes.
Ma'am, actually, I watch sessions recorded. So where can I find the documents which you share in the live sessions?
Here under SWI source code, you have
Ma'am,
this supplementary contents, right?
yes, ma'am.
In your dashboard.
Yes,
So
ma'am.
there
Yes,
is one tab as solve with instructor source code. Under that you will find all the relevant documents.
ma'am. One
So
more
when you
thing.
click this download now, then you will see all the documents.
Okay, ma'am. Thank you, ma'am. One more thing. Can I ask?
Yes.
Ma'am, actually, I am doing Mad One theory and project in this term only, so I need some guidance related to it. So how can I connect to you directly?
There will be project sessions.
Okay,
So you
okay,
can ask your doubts in the project sessions. They are
okay, ma'am.
planned on Monday, 4 to 6.
Okay, okay,
Yeah.
okay, ma'am. Thank you.
Now we will move forward to the next question. A certain network connection with a bandwidth of 12 Mbps. So I hope this question is uh, like you are able to get this question. Okay, this is important concept. Now we will see next question. A certain network connection with a bandwidth of 12 Mbps allows making 4,000 requests to the server per second. If each request is modified
Hello.
to have an yes,
Okay, ma'am, nothing. Mic
if
wasn't
each
working.
request is it fine now or still not working?
It's working now. Yesterday, from yesterday, it wasn't working.
Uh, till what point I was
No, no,
audible?
no, no, not yours, mine. I'm sorry.
Okay, yours.
Yeah,
Okay, actually
sorry.
I have this mic issue. That's why.
No, no, no.
Okay.
Sorry, sorry.
Certain network connection with a bandwidth of 12 Mbps allows making 4,000 requests to a server per second. If each request is modified to have an additional data of 6 KB, what should be the additional bandwidth required to maintain the rate of 4,000 requests per second? Now note this one thing. What is asked? What is additional bandwidth required? It is not asked that what will be the total bandwidth when this file got changed. Okay, what is the additional bandwidth that is asked? Okay, so we will calculate the new bandwidth and we will subtract the old bandwidth from it. That will be the additional bandwidth required. Okay, so this may confuse you. You may calculate the new bandwidth and you will mark it as answer, and it is also given in the option. Okay, so just read the question properly. What is asked? Additional bandwidth required. Okay, so we will first calculate the bandwidth. Sorry. Uh, so bandwidth is equals to number of requests per second into size of request. So what is my first size? The first size of request is, we will have to calculate that. Okay, so what will be my size of request? Bandwidth divided by number of requests per second. Okay, so it will be equal to 12 Mbps divided by 4,000. Okay, this will be equals to 4 threes are 12. So here also I can write it as 12,000 kbps, right? 1 mega is equals to 10 to the power 3 kilo, right? 1 mega is equals to 10 to the power 3 kilo. Okay, so I will write it as 12,000 kilo bits per second divided by 4,000. Okay, so this will come as 4 threes are 12, 1,000 will be cancelled. So my answer, and per second will be cancelled because this is request per second. So the answer will come as 3 kilo bits. Okay, now it is given as the additional data. The each request is modified and additional data is 6 kilobytes bits. Sorry. So now my new size will be 3 kilobits plus 6 kilobits. This is equals to 9 kilobits. Okay, we have not converted into bytes, it is in bits only. Now what will be new bandwidth? What is bandwidth? Number of requests per second into size of request. Now the number of requests per second are given as 4000, so this will be equals to, new bandwidth will be equal to 4000 into, what is my new size of request?
9
9 kb.
9
Okay, so here uh, this kilo multiplied by 1000 becomes megabits. Okay, and it is request per second, so the answer will come as megabits per second. 4 nines are 36, so this answer will be 36 megabits per second. Okay, now we want to calculate the additional bandwidth required, so it will be equals to 36 minus, my original bandwidth was 12, so this will be equals to 24 megabits per second. So the answer will be 24 megabits per second. Is it clear, or shall I explain it again? Is it clear to everyone?
Excuse me, ma'am.
Yes, ma'am.
Yes.
Ma'am, why can't we calculate directly, like 6 KB is the additional data, right? So the size of the additional request into the number of requests per second, even that way we can calculate, right? The additional bandwidth.
What will the number of request will change?
No, in this case,
What if
I'm
the
saying.
number of request
Yeah,
will be?
in this
Yeah,
case,
in
I'm
this
saying.
case, yeah, in this case you can directly calculate as 6 into 6 multiplied by this 4000
4,000. Okay.
additional. Yeah,
If
you
it
can directly
changes, then
calculate
then
from that.
then we have to go by this method. Yes,
Yeah.
ma'am. Got it.
So like this is for your conceptual understanding, or here as the requests are also same, so directly you can also calculate as 6 kb multiplied by 4000, so you will get the additional bandwidth required. Okay, just forget it if some are not getting this, just follow this process. Okay, so we were given the bandwidth, from that we calculate the size of request. Now the news, there was addition of 6 kilobits, so we calculated the new size of request. Now we were asked what is bandwidth, so for bandwidth we use this formula, number of requests per second into size of request. We got the answer as 36, but in the question it was asked what is the additional bandwidth required. That's why the additional bandwidth required will be new bandwidth minus old bandwidth, which will be equal to 24 megabits per second. I hope this is clear to everyone. Now we will move forward to the next question.
Ma'am,
Yes.
ma'am, if the requests are different, then we can approach this method now.
Yes. This method
Okay.
will remain same for like any condition, because this is generalized method. Okay.
Yes, ma'am.
So here what will happen? Suppose if it is given as 5000, so here you will get new bandwidth. So we will multiply by 5000. So you will get some value. Then you will calculate the additional bandwidth. Okay. So this is generalized formula, generalized way for the calculation. Now we will move forward to the next question. A client sitting in a train is connected to a server through a network tower that has a range of 4.5 kilometers and a constant bandwidth of 5 Mbps. Okay, the train is at a negligible distance from the tower and is moving away from it at a speed of 180 km per hour. How much how much data in megabytes will be used by the client before the train completely moves out of the coverage area, assuming that the client is consuming the entire bandwidth. Okay, so here these two concepts are used. First thing is the speed equals to distance by time. From that we will calculate time, that concept. And second concept is bandwidth. Now what I said, there is one more formula for bandwidth. So what is the unit for bandwidth? It is megabits per second. So you can also write it as data transferred per second. From the units, what you can write, bandwidth is equals to data per second. So if we want to calculate the data, How we will calculate the data? Data will be equals to bandwidth into time. Okay, so now we have this bandwidth. Okay, now we want time to get the data. So first thing is, the client is sitting in a train and it is at a negligible distance from the tower. Okay, assume this T as tower. Now client is sitting in a train which is at negligible distance from the tower. Now the client is moving away from this tower. Okay, now the range is given as, network tower range is given as 4.5 kilometer. Now the client will consume the data only in this network range. If it goes beyond this 4.5 kilometer, there will not be any range, so there will not be any data consumption. Okay, so the data will be consumed only in this range. Beyond this, there will not, beyond this 4.5 kilometer, there will not be any range, no network, so there will not be any data consumption. That's why if we want to calculate time, first how we will, so that's why for this data, the data will be consumed only in this range. So we will calculate how much time the client was there in this range. Okay, so how we can calculate that? So first, bandwidth is equals to data per second, data transfer per second. So this will be, so from that, data is equals to bandwidth into time. So we have the bandwidth. Now we want time. So what is time? Time is equals to distance by speed. The train has speed of 180 kilometer per hour. From that we can calculate time. 180 kilometer per hour divide by the speed. Sorry, I did the reverse. The distance is 4.5 kilometer. Distance upon speed. Now this is kilometer per hour. I can also write it as kilometer per hour. So this R will go into numerator. We know 1 hour is equals to, this is equals to 3600, or this is equals to 60 minutes, which is equals to 3600 seconds. Okay, so that's why we will multiply this. So this will be equals to 4.5. Now this R is in denominator, it will go to the numerator. That's why we will multiply it by 36,000, 3600 divide by 180. Okay, so now this answer will come in seconds. So this 180, 2s are 360, 20 into 4.5. So this will be equals to 45 into 2. So it will be equals to 90 seconds. Okay, now we have calculated the time. Now we want to calculate the data. So what is data? Bandwidth into time. What is bandwidth? Bandwidth is given as 5 megabits per second. 5 megabits per second. Okay, when we multiply this by 90 seconds, so this will be cancelled. Per second into second will be cancelled. So my answer will come in terms of megabits. So this will be equals to 5 nines are 45, 450 megabits. Note one thing, this is in megabits, but the answer is asked in megabytes. So how we will calculate in terms of megabytes? Anyone?
Divided by 8.
Yeah, we will divide it by 8. So don't mark the answer as 450 megabytes. We will have to divide it by 8. So this will be equals to, I think, 56.25. Can anybody confirm this?
Yes, 56.25.
Okay, this will be the answer. Any doubt in this question? Shall I explain it again? Any doubt in this question?
Ma'am, bandwidth part data per second, but you said the formula is number of requests per second into size of request. Like it
That
is
is also valid. That's what I said.
okay.
Yeah.
Ma'am, can you explain this formula? Data is equal to bandwidth into time. How it came?
Okay, we did it by unit balancing. Okay, so you can consider it like, suppose I have only one client, and I have Wi-Fi connection. It has say 1 Mbps. Okay,
Yeah.
so and there is only one client.
Hmm.
Let me take some names. Okay, now suppose we have Harsh. Harsh is using his Wi-Fi connection, and the speed is 1 Mbps.
Hmm.
So only Harsh is consuming all the data.
Yeah.
Okay,
Hmm.
so it will be 1 Mbps you are consuming per second. So only you are consuming. Okay,
Hmm.
now if along with Harsh, Piyush and Anurag are also added to that bandwidth, like if you, Piyush and Anurag, all of three are using that bandwidth, so that bandwidth, and all of you are using 1 Mbps. So the total will be 3 Mbps, or else you can say like that. If 1 Mbps is the connection and all three of you are using, then it will be divided amongst three. Okay,
Yes.
but here, so you can say the data is transferred right per second.
Hmm.
So here there is only one client. Okay, and from the formula, this is 5 Mbps. Okay,
Hmm.
so if we focus on the formula, that is if you focus on this unit, it is Mbps,
Hmm.
that is megabits per second.
Okay.
Let me write it over here. It is megabit per second. You
Hmm.
can also write it like this: megabit per second,
Yes.
right?
Hmm.
From the same unit. What is megabit? It is data.
Yes.
And what is seconds? It is time,
Hmm.
right? If
Yeah.
you want to calculate this data, what you will do? This is in denominator, right?
Ah,
You
yeah.
will multiply this Mbps into seconds.
Hmm.
This is how you will get MB. That's
Yes.
what I said. Data is bandwidth is data per second, data transfer per second. So
Oh,
data will be equals to bandwidth into time.
okay. Okay. Thank.
Is
Thank
it
you.
clear now?
Yes. Yes.
Okay. So two things were there. This formula, this unit balancing, and the second thing is regarding this range. So if the person, we need to understand this. If the client goes beyond this range, there won't be any data consumption. That's why we will calculate the time for this distance only. Okay, these were the two concepts. So this is how we calculated. So the answer came as 56.25 MB. Don't mark it as 450. Okay, always take care of the units. Now we will move forward to the next question. Any doubt in this question?
Ma'am,
Yes.
uh, will they give the all the formulas in the quizzes, or we have to memorize?
It has all the formulas, right? It is already there in this document, and I will share this document with you.
No, no, ma'am. I am asking. In the quizzes, all the formulas will be given.
No, you will have to remember that, right?
Okay,
How
okay,
we
ma'am.
will give the formula? Yeah, you will have to remember the formulas.
Okay, ma'am.
Excuse me,
Okay.
ma'am, I have a small doubt.
Yes.
Ma'am, I think the bandwidth will keep changing, right, as the train moves. We can't take it as constant.
Why it will change?
Ma'am, because the distance will change from the tower and latency will come into play, so the data transferred per second will change if train moves.
No, why bandwidth will change?
Ma'am, if train moves, the distance will change. So the data transferred per second will also change. No?
Mm, okay, I will get back with you on this.
Okay, ma'am,
But
thank
I
you.
think the answer should be this only. This is the way for calculating this answer.
Yes, ma'am, but
But
I
still, I
think
will.
the doubt is
Yeah,
conceptual, I guess.
yeah, I will think on that and I will get back.
Okay,
Thank you.
thank you.
Ma'am, what was the question?
What?
What was the question he asked?
He said that the train is moving, right? So the bandwidth should change. That is what he is asking. Even though it is said that bandwidth is remaining constant, but if is there any possibility, I will have to check. I will get back on this. Okay.
Okay.
Then there is another question again on bandwidth. So consider this graph that represents the variation in bandwidth of a network for an entire day, that is 24 hours. Three users were connected to the network at three different times of a day. What is the total data consumed in gigabytes by all the users in 24 hours? Okay. Again, bandwidth is equals to, so we have this graph. In x-axis we have hours, on y-axis we have this bandwidth in megabits per second. So this is the variation of bandwidth. Okay. So we have these three users who are using the data at these different intervals of time. So we have to calculate the total data consumed. So how we will calculate? Bandwidth is equals to data per second. So data will be equals to bandwidth into time. So how we will calculate? So first, for user 1, the bandwidth is 8 megabits per second, and the time is 4 hours. So this is 8 into 4, okay, plus for user 2, the bandwidth is 6 and the time is 12 minus 8, that is 4. So we will multiply 6 into 4 plus, now the band for interval 12 to 14, the bandwidth is 8 and the
Two
hour,
into eight.
the duration is 2. So it will be equals to 8 into 2 plus, for user 3, the bandwidth is 2, then the duration is 4 hours. So this will be equals to 2 into 4 plus, now the bandwidth is 4 and the duration is 4. Okay. Now we will focus on the units. Okay. Bandwidth was given in megabits per second. Megabits per second multiplied by, this is the time in hours, right? So we will multiply it by 3600 to convert it into seconds. Okay. Now
Ma'am, can you come again?
we need,
Implementation of the formula for each user.
okay. Now for user 1, the bandwidth is 8. Okay. Focus on the y-axis. The bandwidth is 8.
Yes, ma'am.
Okay. And what is the duration? 4 hours.
4 hours.
So we multiplied 8 into 4.
Okay.
Okay. Now for user 2, this is the graph for user 2, like
Mm,
this. Okay. So what is the bandwidth? 6. Correct. And the duration is 12 minus 8, that is 4 hours.
4 hours. Okay.
Okay. Again, now we have this peak. So here the bandwidth is 8, but the duration is from 12 to 14 hour, 14th hour, right? That is 14 minus 12 equals to 2. So we
Okay.
multiplied 8 by 2. After that we have user 3. Now this is the graph for user 3. Okay. The bandwidth is 2 and the duration is for this peak, the duration is 20 minus 16, that is 4. Okay. So we multiplied 2 by 4. After that we have this peak. Again user 3 is consuming the data. Okay, here the bandwidth is 4 and the duration is 24 minus 20, that is 4. So we multiplied 4 by this 4 by this 4.
So we
Okay,
will
this
have
is what
to
we are doing. How we will calculate data? We multiply bandwidth with the time. Okay, so here on y-axis bandwidth is given, on x-axis time is given. So we are taking the bandwidth from y-axis and multiplying it with the time on x-axis. Is it clear?
right, ma'am.
Okay, but now we need to balance the units as well. Now the bandwidth was given in megabits per second, right? Megabits per second, and the time is given in hours. So what is 1 hour? 1 hour is equals to 3600 seconds, right? So we multiply it by 3600. Now this second got cancelled. Now this is megabits, but the data consumption is asked in gigabits. I mean bytes. Okay. So we will now divide this by this total. So we will calculate this and divide it by 8. Why we are dividing it by 8? When we divide it by 8, we will get the answer in megabytes.
Bytes.
Right? Now we will get this answer in megabytes. Now this is 8 4s are 32 plus this
It's
is 32.
96 into 3600, the total of
Okay.
all the four.
96 into
3600
3600.
MB. Okay, you
Okay.
have divided there.
Divided by 8.
Divided by 8 MB.
It'll be
Divide by
4,
8.
43.2 GB.
Yeah, 43.2 GB is the
So
whole calculation.
So it will come as, if we calculate in terms of MB, it will be 43200, right? This will be in MB.
Yeah.
Now we multiply it by 10 to the power minus 3 to get in GB, right? So this will be equals to 43.2
43.2 GB.
GB. Any doubt in this question?
Excuse me, ma'am.
Yes.
Ma'am, I have a doubt. Ma'am, like for the, ma'am, can you go to the graph?
Hmm.
Ma'am, like in user 3, for the second case, 20, you have taken 20 minus 24, which is 4. So we won't take like 4 minus 2, or we have to consider full, like from 0 to 4 only. For the vertical one, like for the second case, it is from 4
Hmm.
to 2. So we won't take 4 minus 2.
No, because just focus on this peak, right? Here the bandwidth is 4, not 4. Why will take 4 minus 2? Here the bandwidth is 4, right? So just focus on this rectangle. It has this width as 4 and the length as 4 and the width as 4, right? So this will be the total the data consumption. The area
Okay,
of this
ma'am.
rectangle will be the data consumption.
Okay, ma'am.
That's why we are taking 4. Just like what you have to do, whenever, if so suppose it is for user 1, okay, just focus on this line. So it will give you the bandwidth for y-axis, and focus on the x-axis where it is intercepting. Okay, so here it is intercepting at this point. So here the duration is 4 hours, and here this is intersecting at this point, that is 8. So here the bandwidth will be 8. Like that you will have to use this graph. Is it clear?
Yes, ma'am.
Okay, don't focus over here. Here, if we here the bandwidth is 4 and not 4 minus 2. Here for duration you will have to calculate. How we will calculate this width? It will be 24 minus 20, right? Because only for this duration, or for simplicity I will take user 1. Okay, here the bandwidth was 8, and if you want to calculate this duration, it will be 4 minus 0. Okay, for this user 3, for this peak, What will be the duration? It will be 24 minus 20. So here we need to subtract for the duration. But here the bandwidth was given like this only. That's why we are taking 4 into 4. Okay.
Yes, ma'am. Yes, ma'am.
I hope this is clear. Now we have one more problem on concurrent viewing. Okay. Uh, a certain video on the web occupies 2 megabytes of memory of the server. If there are 5 million concurrent viewers of that video, assuming that each viewer requires an individual connection to the server to view the video, what should be the minimum RAM requirement of the server that can process all the viewers simultaneously? Okay. Now we will first see the concept. Now I have shared this YouTube link with you. Okay. Now Piyush wants to watch that session. Piyush went to the YouTube and started watching the session, right? Okay. Now Vishnu also got the link, and now Vishnu is going to watch that session. So suppose Piyush has watched that session till 30 minutes. So now when Vishnu is trying to watch that session, so Vishnu will see after from 30 minutes, or Vishnu will see the video from starting.
From starting.
Vishnu will see the video from starting, right? So this
Right.
is the
Starting.
concept behind that. Okay. So what happens? This is server. Server is having that video. Okay. So here it is given as 2 megabytes of memory of the server. For that, the video has 2 megabytes. Is of 2 megabytes. Okay. So what happens? Server is having that video. What will happen? Suppose when Piyush was watching the session, the instance of that video will be created on RAM. Okay. Now, when Anurag went to watch that session, another instance of that same video was created. So, what is happening? Suppose what I said for Piyush, what happened? One instance is created. So, obviously, this is 2 MB. So, this will also be 2 MB video. So, here it will be equal to what we have to calculate the RAM requirement. So, for first client, what will happen? First client into size of video. Okay. Now both Piyush and Vishnu are watching. So now what will happen? Two instances will be created. So so what will be the RAM requirement? Two clients multiplied by size of that video. Okay. Now Jigyasa is also watching that session. So now we have three clients. So we have Piyush, we have Vishnu, now we have Jigyasa. All of them are watching the session. So what will happen? What will be the RAM? Again, one more instance will be created. So it will be equal to 3 clients multiplied by size of the video, right? Similarly, for n clients, it will be equal to n into size of video, right? So my RAM requirement for n will be for n clients will be equals to n into size of the video. Why? Because for n clients, n instances will be created, right? So what will be the RAM requirement? So for first client, first instance was created. For second client, second instance was created. So the size of RAM is increasing according to the instances and number of clients. So now if we have n clients, so we will have n instances created on the RAM. So it will take n into size of the video. Now, what is the question? In question, we have 5 million concurrent viewers, right? So now, for 5 million, what will be the RAM requirement? RAM requirement will be, we have how many viewers? We have 5 million viewers, which is 5 into 10 to the power 6, that is 5 million, and the size of video is 2 megabytes. So this will be equals to, megabyte is 10 to the power 6, so this will be equal to 10 into 10 to the power 12. So the answer will be 10 terabytes. Is it clear, or shall I explain it again? What will happen if the moment number of client increases, the instances of that video are created on the RAM. So for n client, the size of the RAM will become, RAM requirement will be n times the size of the video. So for 5 million concurrent viewers, the RAM requirement will be equal to 5 into 10 to the power 6, that is million. For 1 million, it is 10 to the power 6 units, multiplied by what will be the size of video? 2 MB. So we will multiply it by 2 MB. So the answer is 10 terabyte. Is it clear?
Ma'am, I'm not able to find this document. Can you check once?
She hasn't uploaded yet.
Okay, okay.
I will upload it right after the session.
Okay, ma'am, okay.
Okay, is this question clear? It is simple one. Okay.
Yes, ma'am.
So the
Yes, ma'am.
concept is important. Okay. Now we will see one more question. A server using the inbuilt HTTP module of Python is running for a directory my underscore app whose file structure and content of each file is given below. Okay, so we have this my app as a folder, and inside that my app we have these three files: home.html, first.html, and main.html. Okay, this is the content of all these files. Now what will be rendered by the browser for the URL, for this URL? Okay, so now assuming 8000 is the port of connection, so let me open VS Code.
Ma'am, how many questions are left?
This is the last question.
Okay.
Okay, so I will tell you how to create this. First thing, go to your file structure. Okay, suppose I am in D drive and I have created this my app. So how you will create a folder? You will just right click, new folder. Okay, so this is how I created my app folder. After that, what you will do, you will go to this VS Code. Okay, and here you will find this option, file, open folder. Okay, so if you go to that folder, just go to that folder. I will first show it from here. Okay, so this was my D drive. Inside this D drive, I have this Mad1 folder. Inside that Mad1 folder, I have this my app folder. So I will just select this folder. Okay, so this folder will open. So if you want to add a file to this folder, you will click on this button. 1 minute. Let me increase the size. Okay, so if you want to create a file, you will just select this file. You will just click on this, and suppose you want to create HTML file, you will write test dot and you will give the extension as HTML. Okay, if you want to create a Python file, you will write the extension as .py. So this will create a Python file. Similarly, you can create CSS file, you can give the extension as .css. Okay, so now what is given? We have this my app folder. Inside this my app directory, we have three files: first.html, home.html, main.html. Okay, and we have the content as for first.html. the content is hello from first. For home.html, the content is hello from home. For main.html, the content is hello from main. Okay. Now we will establish, we will create a Python server. Okay. So for that, we will have to write Python -m http dot server. So this will create a Python server. Okay. And you will see this server is available on port 8000. Now, if I write, if I go to this port, if I hit enter, so I will get the directory listing for all the files. So what are the files that I have in that folder? First.html, home.html, main.html, taste.html, taste.py. So if we have created this Python server and if there is no index file in my directory, so it will give the directory listing for all the files. Okay. And if you have this index file, so by default it will render that file, but right now I don't have index.html, so it is giving me the directory listing for all the files. So basically these are the hyperlinks for that file. If I click over here, so it will render this file. So basically this server is serving that files locally. So just focus on this address. So for this address it will render this file. So what was given in the question? For this address it was asked what will be rendered. So for this address it will render the first.html file. If you go back, if you click on this home.html, it will serve this file. Okay. Now suppose we have index.html. Now we will go to localhost. Now you will see that by default, what will happen? By default, this Python server renders index.html file. And if the index.html file is not present, then it will give the directory listing for all the files. Okay. That's it for today's content. Any doubt?
Ma'am, what you have explained in the last question, I didn't get you. Like, what was you doing in VS Code and what you implemented? Is it the content of first week or second week?
Actually, sir has introduced the Python server. So I was telling, I was establishing the Python server. Here, what I did, I created Python server. Okay.
Okay.
This is a command for it. Okay. If you are not understanding, just leave it. You will understand it the moment we will move forward to next weeks. Then you will get it. Okay. If you are not understanding, then not a problem. Here,
No,
what I
what?
did, I created a Python server. So this Python server is serving these files indexed which are there in my directory. So I created Python server for this directory. So it is serving these files. So if I go to, and it is serving the files on the local host. So what happens if index.html by default it serves index.html file. If index.html file is not present, it gives directory listing. So here index file is present in my directory. This is index.html file, it is present. So it is rendering this file. But if this index.file is not present, if I delete this file, so here I don't have index.html file. Now if I go to this local host, it will give me the directory listing for all the files. If you are
No, no.
getting
What
this
I am
fine.
asking is, hello.
Yes, yes.
Am I audible?
Yes, tell
What
me.
what I am asking
Yeah,
is,
you are audible.
you are telling us to do the whole thing you did, or you are just doing this thing to showing
I'm
us.
just explaining. I'm just explaining this thing. Even if you don't get it, not a problem. You will understand these terms while we will see Flask. We will get all these things in more detail. Okay?
Ma'am,
Even
your
if you don't
voice is
understand,
breaking.
just leave it. Hello, am I audible? Hello, is it me?
Ma'am, your voice is breaking.
Your voice is breaking too much in between.
Hello.
Yes, ma'am. Ma'am, can you please repeat the last question?
Hello. Now, please.
Ma'am, it's still breaking.
Hello. Is it fine now?
Yes, ma'am.
I was saying, if you get this problem, it is fine. Even if you don't get it, you will understand it while we are taking Flask. Okay. Yeah, I will share this file right away. If when while we will learn Flask, you will get all these things properly. Okay. So even if you're not getting it right now, not an issue. Okay. While we will run fast Flask, you will get all these things in detail.
Ma'am, can you repeat the last question?
Just forget about the last question now because I think it is creating confusions.
Okay, ma'am.
Or shall I explain it once?
Ma'am,
Yes, ma'am, please.
what I was asking, I
Okay.
haven't set up any VS Code. I don't know how to use VS Code. And you did, you created some folder in File Manager
Yeah.
and you just extracted. So can you teach us how to do all the setup of VS Code initially?
Did you download VS Code?
Yes, I have.
Just open the VS. First, create any folder. Just create any folder. Share your screen. Just create any folder. Hello.
Is my screen visible, ma'am?
Yes, it is visible.
Okay, okay.
Just create a folder.
In File Explorer.
Yeah. I'm telling you the simplest way. There is one more way, like opening the CMD from that path, then opening the VS Code, but it becomes a little difficult for new people. So I'm telling you the simplest way. Just
Folder with
create
name
one
of?
folder, any name. You can give any name. Same add one.
Yes. Now,
Uh, why it is not visible?
uh,
Have you
is it?
selected entire screen or only tab?
Okay, okay. I just selected the tab. Okay. Let me just
Okay.
representing uh, entire screen. Is it visible now?
Yes, it is visible.
I have created a Mad1 folder.
Okay, remove the spaces.
Okay.
You can write mad underscore one. Okay, no issue.
Yes, ma'am.
Okay, now open VS Code. From the search bar, open VS Code.
Mhm.
Okay, now
Oh,
open this VS Code. Okay, did you not install it?
no, no, I haven't installed it. Okay. So,
Okay, just
if you
open
can
it.
give me time, I can install. Just it will take, I guess, few.
Okay, okay.
Next, next.
Yes, Ankit?
Ma'am, I have a question regarding the weekly lab assignment. I have
Yes.
submitted it. I get 100 out of 100 in the test cases, but the private ones I'm getting zero. So how can I debug it? Like, how do I?
The private case will run only after the deadline.
Oh, okay. So I don't have to worry because
Yeah.
in
No,
the
no, no.
last semester for Python we used to see the result of the private ones also on submission. So it should be
No. You don't need to worry about that. The private test will run only after the deadline. Okay.
okay. Got it. Thank you.
Yeah.
Yes, ma'am. Are you able to see my screen?
Yes, it is visible.
So, what to do
Just
now?
select any. Select anything.
Okay, dark mode is
Dark thing.
good. Good. Now, uh, code with extension.
Just close it.
How? Upper.
Yeah.
Can I speak in Hindi for now?
Yeah. Fine. No issues.
ऊपर से कट कर दूं वेलकम वाला.
हाँ.
Okay. अब
Okay.
इसके आगे
Now
क्या
go
है?
to file. हाँ, file में जाओ.
Mhm.
Now you will see the option open folder.
Open folder. This one.
Yeah.
Okay.
Now open
There is
that
a
folder.
simpler way. You
I
can
know with the help of shift right click, but this option is not available for everyone.
no. You can directly just drag and drop the folder in the window.
That also
Okay.
you can do if it is easy.
This folder I have to select.
Yes.
Uh,
Go go back. Yeah. Select this folder. अब ये folder यहाँ appear हो रहा है, right? Say yes. I trust the authors. Just check it box. Just check it.
हाँ यहाँ पे साइड में ये आ रहा है मैड वन का.
Yeah.
Mhm.
So वहाँ पे जो first option दिख रहा है, you can create files with that option. Okay. उसके बाद
Okay.
जो दिख रहा है, you can create folder. Okay.
Okay. अभी
Like that,
मेरे को
you can
दोनों का
create.
आइडिया नहीं है तो आई डोंट नो व्हाट इज फाइल एंड व्हाट इज फोल्डर इन इट.
Folder is just a folder.
ओके.
You have created one, right? Mad1.
हम्म.
Like that,
वो
you
तो
can create folder inside this Mad1 folder with the help of this.
ओके.
Okay. Just don't worry about this as of now. You
हम्म.
can, okay, you can simply create files with the help of the first option, right?
दिस वन.
Okay. Yeah.
ओके.
Okay. So now you can stop sharing your screen and you can follow the session. Okay.
ओके, थैंक यू.
Okay. Any other doubt? Yes, Bhumika?
Ma'am, can you take PA question number 1?
1 minute. Practice assignment question number 1.
Yes, ma'am.
Ma'am, I am not able to open any folder in VS Code.
Why? I have shown you. Are you not following that same?
Yes, ma'am, I am following the same step, but it is not opening. I don't know why.
Share your screen.
Yes, ma'am. It is not opening.
Mm, Can you try reinstalling VS Code?
I have tried it 2 times, but it is giving the same problem.
Try closing the welcome and then
No, it is not happening.
try dragging and putting it into VS Code, any folder.
No.
I think the folder has been opened. You just need to select the first icon, not the second one.
Can you
Not the
repeat
second
it
one.
again?
Select the
Hello?
first one. No, no, the folder is okay. In the VS Code, top left corner. No, not that. Below the VS Code icon, select that icon and create a file here. Yeah,
Hmm.
just create any file and it is now in opened in VS Code.
Your folder is already open, I guess, right?
Yeah, you just
Yeah,
try
it is
naming
open
something.
only. Just go to that folder from File Explorer. File Explorer. Go to your File Manager. File Manager,
Yes,
I
ma'am.
said, not VS Code. Open that folder. Yeah, working fine only. It was already open.
Is it okay?
Yeah.
Yeah, it's fine.
Okay, ma'am.
Ma'am, can we leave if you are done with this session?
Yes, you can leave.
Thank you, ma'am.
Kindly share the
Ma'am,
PDF.
Yeah,
could you share the document here also? Just the link so we can.
yeah, I will share it.
And where will you be sharing the other documents?
It is already there in the supplementary contents.
Supplementary contents. Okay.
Yeah, you will find SWI source code tab. Under that, if you click download now, you will see all the files.
All right, ma'am.
Okay, just give me a minute. I will share it right now. I have shared it, okay? You should be able to find it.
Ma'am, can you share that command for creating that Python server again?
I'm putting it in the chat.
Okay, okay, ma'am. Thank you.
Python. Okay, that's all for today's
Yes, ma'am.
session.
Okay.
Okay, thanks everyone for. Yes, Bhumika.
Thank you, ma'am.
Ma'am, that
Yeah.
from the practice
Oh,
one.
yeah, your question. First question. Okay. This is similar to what professor has discussed in the session, right? So what is this command while true do? So it will run this loop unless we are killing the program. Okay. After that we
Ma'am,
have
are you
echo
sharing the
hyphen.
screen?
Yeah, 1 minute. Okay. Is that visible now? So basically it
Yes,
will
ma'am.
run this loop unless we kill this program. So what is written echo hyphen e. So here it is given as today's date and time is hyphen n slash n slash t date. Then we are passing this through. We are using this pipe symbol. We are passing this information through netcat hyphen l localhost 3500. So basically, what is doing? This is a simple code for simple web server. Echo hyphen e means it will simply print the data. Okay, and we are passing this data through this netcat hyphen l. So it will listen on this port 35,000. So you will get output on this port. So basically what it is typing, it is giving me the date or the current date. Okay, now what is said, like if the program is executed in one terminal and is waiting for a request, then what is the client part that generates the request? Now here we will be running the server on one terminal. So if you want to work as a client, we will open another terminal and then we will type the curl command. So here the port number is specified as 3500. So we will write the curl command curl http hyphen slash slash localhost 3500. So we will open this in another terminal because on one terminal my server is working, right? That's why I will open this. I will write this command in another terminal. So basically this is acting as client. This curl http, this curl url, this method is basically working as a client. So it will send the request at this port 3500, and at this port I will receive the response as the current date. I think you should refer the session which is taken by professor. You will get detailed idea about this.
Okay, ma'am.
Okay.
Yes, ma'am.
Any other doubts? Okay, that's it. So thanks everyone for joining. We will see you in next session. Thanks
Thank you, ma'am.
everyone.
Thank
Thank
you,
You can
you.
ma'am.
drop off.
Thank you,
Now can
ma'am.
drop.
Thank you, ma'am.
Thank you, ma'am. I hope all the concepts are clear to you all. I have already shared the document. Okay, so it is important one. So just go through it again if you didn't get it. Okay. Thanks everyone for joining. And stop the sharing.
Thank you, ma'am.
Ma'am, hello.